this clear a bit? Well, that's actually quite nice, because now we have, we're almost there. So we have that the process M-born, and we already argued that really that's all we need to consider. We can ignore the remainder. Can be written as epsilon mu of k times sum over I m a goes to b 2 pi mu 2 pi mu over minus 2 pi dot k plus the sum over j m a goes to b 2 pj mu over 2 pj dot k. So when k goes to 0. Notice I've also dropped the I here because, and the j there, because if k goes to 0, you can more or less say, well, pi still goes into the process here and j still goes out of the process there. And you really see here the singular behavior as k goes to 0. Now we demand that k mu on times, well, this thing, mu is 0. So if I remove this epsilon mu but replace it by k mu, it should be 0, the current conservation. Well, we can now do it by, oh, you should have warned me, I forgot something. Fi of k squared of 0, and here f1, well, fi, and here fj of 0. Forgot the form factors here, right? It's still there. Okay, these are the actual charges. Okay? So far, following me? Now comes the last and final and crucial step. If I replace this by k mu, I'll just see what I get. Well, you can immediately see. I can contract this with k mu, and I get minus 1. I contract this with k mu, and I get plus 1. This m to ab comes out. So if this is 0, that's sum over I, fi of 0 minus sum over j, fj of 0 is 0. So charge is conserved. So it's a nice, very general diagrammatic proof of current conservation, all following from the abelian gauge principle, perhaps in a way that you haven't seen it before. It also shows a bit the power of a diagrammatic analysis and a general diagrammatic analysis, which we will do more of.
What does it physically mean to have two form factors?
There's only one form factor.
One of them is 0.
Sorry?
Only one 0.
F2 was 0, yes. And we just not. We wrote it down at first as the most general thing, but then when we demand that current conservation, turns out one of the two is just 0. It is not always true in electrodynamics. You can have the charge and the magnetic coupling, so that can sometimes happen. But in this case, we just look at the electric charge. And that's the one that is, particularly when you have a soft photon emission, low energy photon emission, really comes to the fore. Of course, it had to be like that. If the operator language is consistent, and the proofs that you may have seen in quantum field theory are certainly not wrong, they're in books after all, then, but this is a different way of looking at it. And it gives a more direct connection to current conservation in momentum space for amplitudes. So that's all I want to say about abelian gauge theory.
Can you just, sorry, what
Yeah.
exactly did you just show there when you at that last line? What exactly does that?
that the sum, so Fi is the I dropped the index 1 here because that's just the charge. I call it F at the charge. So F of 0 is the electric charge of the photon coupling to line I. Right, that is this particular interaction. And this, what I've proven here is that the sum of all these electric charges in the initial state is the same of all the charges in the final state. So charge is conserved. And it's only true because of this condition. Current conservation in momentum space. So who has seen this before? No one? So there's always something, even in the Abelian gauge theory, even if it's quite familiar, one can have different ways of looking at things. The unfortunate thing is I'm running one lecture behind. So
We'll have an extra lecture sometime.
um,
Or we can convert one of the tutorials into lecture duration.
you should maybe do that, because it would be nice if we had a little bit of non-Abelian gauge theory ready today, right? So
After lunch we have one lecture and then tutorial.
yeah, and then the shorter tutorial, something like this, where we can maybe just ask questions, and maybe a few of you can work on some problems. Yeah, let's do it that way. Okay, then non-Abelian gauge theory after lunch. Of course, anytime you want to ask me questions, just approach me, right? So happy to try and answer your questions. I will maybe not be able to answer all of them. I'm sure I will not be able to answer all of them.
There's a couple of announcements. One is that when you go to CBS guest house, please wear your tags, because they want to make sure that the people who are coming and going are guests. Second is the Wi-Fi in CBS will be set up probably by evening or tomorrow. So just be patient. In this room there are 3 passwords. So these are the connections. Okay, and all the 3 have the same password. Can you read it? It's very simple. A1, B2, C3, B4, E5. So you can, it's good. I mean, I just checked, this connection is good. That is in this building.
B class 1,
B class 1, B class 2, B class. And probably in your sitting room next door also it should work. We just check. This is the password for all. A1, B2, A1, C3, B4, E5. So we break for lunch and we come back at 2 o'clock.
So if this level is too low or too high, just let me know, right? Then I'll see what I can do. I may get all these remarks at once, and that's hard to judge. But at least it's good if you know. Well, some of you already said that particularly external lines is something to repair, maybe to at least have first look at. Maybe group theory for some of you. So just let me know. We'll see.
Ma'am, can we have introduction? Like we can introduce ourselves to sir, so that we can have.
Of course, yeah.
That will be better to have.
We'll check if the lunch has not come. We'll do it now. Otherwise, we have it after lunch.
Yeah, that will be better to do.